Hello everyone, welcome back to my YouTube channel. So far, we have seen the embedding model from the RAG pipeline. We have seen how we can create the embeddings of the documents that we got from processing it with the help of different chunking strategies that we have seen before. Now that we have created embeddings of the document, now comes a question where to store those vectors of the document. There has to be a storage area where the document embeddings of the document will be stored, and that is nothing but vectors too. And yes, you guessed it right. In this particular video, we'll be focusing on vector databases, what exactly vector databases are, and what are the wonders of it. So without further delay, let's start. As usual, first we'll look at the official definition of the vector databases. And the definition says that a vector database is a specialized type of database that is designed to store, manage, and query vector embeddings, enabling advanced similarity searches and other AI-driven operations. In the previous video, we have seen what are the different operations that we can perform on the vector embeddings of any form of data. In their vector form, it also enables this particular advanced strategies of similarity searches, that is nothing but to find out the closest entities and other AI-driven operations like recommendation systems. It enables keyworded as well as semantic searching strategies, which further helps to get the better results for the further RAG pipeline. So I hope the definition of vector databases is clear to you all. Let me read your mind. I'm sure you might be getting one question. And is this that question? Are these vector databases different from the relational databases that we once have used? I'm sure you might have used the relational databases at some time before. So you might be wondering about whether these vector databases are seen as the relational databases. And if yes, why it has been given a name as vector databases and why not the relational databases itself? The answer to this particular question, that whether they are same or different, so let me tell you that yes, they are different. Vector databases and relational databases, they are different from one another. Now you might have got one more question. Let me guess it. Is this the question that if the vector databases are different from the traditional relational databases, then why there is a need to create a different concept called as vector databases? Why do we need the vector databases if we can store the embeddings in the traditional databases as well? Obviously, traditional relational databases are created to store the data. Now, data can be text, image URLs, numbers, floating points, arrays, as well as vectors. Yes, you can store the vectors also in relational databases. Then why do we need the vector databases? I'll explain you every single need why we require the vector databases with the help of multiple examples. Now you'll be getting an idea about vector databases only when I try to feed the vector embeddings in traditional databases like relational database. So let's try to do that. Now let's say we have some vectors. We have this particular vector 1. You can see in this particular vector, we have total 10 dimensions. And each dimension is a floating point integer. Let's say we have multiple such other vectors. Let's say we take 5 different vectors of the same dimensions. Total we have 10 dimensions over here for each and every vector. Let's say we store this particular vectors, these 5 vectors in relational database. Now why we can store these vectors? Because you can see these are simple array, and in traditional databases we can store arrays also. So let's say we have stored this particular 5 vectors in this particular database. Now it's easy, right? We can store it in relational database. But what about different cases? Let's see them one by one. The first case is that when you have this particular type of vector where we have multiple dimensions. Let's say we take 1000 to 2000 dimensions or more. This particular vector is 1000 to 2000 dimensional vector. It can be more than that too. Now, in this particular case, if we try to store this particular vector in this particular database, then it's hardly possible. It's very difficult to store this particular vector of this many dimensions in this particular database because relational databases have some fixed length of each and every value. There is some fixed value that this can hold. And if value exceeds, then it won't work at all. It won't try to feed the data into it. So here you can see the very first reason why we cannot use the vector database to store the vectors or the embeddings of the document is because of the high dimensional length of the vectors. Now, in real world scenarios, the vectors are not only limited to 10 to 20 dimensions. In real world cases, the vectors can be more than 2000 dimensions also. Because I already told you in the previous video that more the dimensions we have for a particular vector, more accurately we can define the semantics of it. So obviously, in real world scenarios, we require high accuracy, and for that, we require high dimensions for each and every vector. And because of the high dimensions of vectors, we cannot store it in relational database. So this is the reason why. Now let's see another case where we have this particular vector. Here you can see this particular vector is a simple vector of 10 dimensions. Now let's say we have one more vector, and similarly, we have such n vectors. Now this n can be any number. Let's say we have millions of such n-dimensional vectors. Here I have only specified 10 dimensions for each vector, but let's say we have millions of such n-dimensional vectors. So here not only the length of the vectors has increased, but also the number of vectors has also got increased. So in this case also, we got a reason that it's not appropriate to use the relational databases. Instead, we can go for the vector databases. And the reason is increasing number of vectors. Now, this is only the second reason. Let me tell you about the third reason. Let's discuss this particular scenario. Let's say we have this particular vector and so on. We have total n vectors. Now stick to this particular scenario. Now in the previous video, I already have told you how powerful vectors are, how useful they are. We can use these vectors to find out the similarities between the entities. We can capture the semantics of data with the help of these vectors. Now let's say we have this particular n vectors of n dimensions in a relational database, and then we have to perform the searching operation onto it. So do you think it will be an efficient way to perform the search operation onto these particular vectors that are stored in relational databases? As you know, relational databases are designed to perform the exact match between the query and the data stored in it. Here, we are not supposed to find out the exact match. Instead, we have to find out the similarity. So in this particular case, we cannot use the relational databases. Now let's take this particular scenario also where we have to find out the exact match. Let's say we need to find out the exact match of a particular queries vectors in the millions of n-dimensional vectors stored in the vector database. Now to find out the exact match, how it will go? It will take the embeddings of the query and it will try to find out the match one by one, starting from the vector one stored in the database. So it performs a linear search. So now if we have millions of such vectors, it has to go through millions of such vectors to find out the exact match of the embeddings of the query. So do you think that is an efficient way? No, right? So this is one of the reasons why we cannot use relational databases for storing the vectors. And that is nothing but the similarity search efficiency. Now let's talk about one more reason. Relational databases are not designed for seamless integration with AI/ML pipelines, making it difficult to perform real-time embedding updates and similarity searches needed for AI-driven applications. Now, as you know, relational databases, they do not have the capability to perform integration with the AI/ML pipelines, for example, the RAG application of generative AI. So in such scenarios where we have to integrate the databases with the AI or ML pipelines or flow, we cannot use the traditional database. So this is one of the reasons that is integrating with AI ML pipelines or workflows. So I hope all the four reasons are clear to you all. And I'm sure that these four reasons are sufficient for you to use vector databases to store the vector embeddings of the documents. Now that we have seen the difference between the relational and vector databases, and we also have seen different points related to it, let's summarize the advantages of vector. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link And do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. The very first advantage is data management. Vector databases simplify the data operations like insertion, deletion, and updates. Unlike standalone vector indexes, which require additional integration work, vector databases has inbuilt functionality to store the vectors efficiently as well as to perform the searching operation efficiently. So the data management is one of the advantage to use the vector database. Next is metadata storage and filtering. This store the vector database store the metadata with vectors, allowing for more precise querying using the metadata filters. So we can not only store the vector embeddings of the document, instead we can also store the metadata of that particular document. Now what exactly metadata is? Metadata is the information about the vectors that we are going to store. It is the information about the document from which the vector has got arrived. Now how this metadata is useful? Let's say we have to debug from where that particular chunk has got retrieved after performing the search operation. So in that case, this particular metadata that is stored in the vector database will help us to find out the actual source from where that particular chunk has got arrived. So in this particular metadata, you can store the document name, you can store the document path, as well as you can store some other unique IDs related to that particular document. So it will be easy for you to track each and every source from where that particular document has got arrived. Third advantage is the scalability. Yes, compared to the relational databases, these vector databases are designed to scale with data volumes and user demands, supporting distributed and parallel processing more efficiently than standalone vector indices. So you will come to know about this when we'll see the internal working of vector databases, where it supports distributed and parallel processing, which is very much effective than the standalone vector indices. The fourth advantage of vector database is real-time updates. It supports real-time data updates, keeping the results fresh without the need for time-consuming re-indexing. So it has a functionality to update the data in a real-time format. It keeps the data up to date as and when it is updated. The next advantage is backups and collections. Vector database has the functionality to handle the routine data backups and allow selective index backup for later use. So over here, internally it create copies so that whenever data gets lost, in that particular case using this particular backup, so we can recover those particular amount of data. The next advantage is ecosystem integration. In vector databases, we can easily integrate with the data processing tools as well as the AI related tooling, streamlining data workflows. This thing we already have discussed that we can integrate the AI and ML pipeline with the vector databases. So it becomes very much effective and useful. So I hope the advantages of vector DBs is clear to you all. With this, we come to the end of the video. I hope you must have got an idea of what exactly vector databases are. In the next video, we'll be seeing the internal working of vector databases, as well as we are going to look into different databases that are used. Stay tuned for that. I hope you like this particular video. If you want more such videos, then please do like, share and subscribe my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.